Okay, Aiden, I'm seeing one. Is your physics class getting better, Aiden?
I think it's all right. It's just that I cannot understand it.
So waiting for your teacher to explain is not always going to be productive.
Yeah.
Okay, I'm going to distribute to the next page. It's not gone yet. I'm just moving it.
Okay.
Okay, move to the next page, yeah, and next. Yeah? So move to page 3 now, yeah. I'm already seeing the questions. They're definitely not the hardest, so it's good to revise your basics. Good.
It's current in static electricity because I haven't started it.
That is static, and that's not the very hard. We can understand. No problem. Good, good. Yeah. These two questions already cover most of the static electricity basics. So if you don't have anything else, I'm okay. You can focus on other topics. All I want to do before your teacher talk is to cover the basics. Then you listen your teacher, there's a hope that you understand better. If not, that's just normal and you just go to questions which again, at that point, you should at least have something from our session, right?
Yeah.
Okay.
Wait,
That's it. Yes, Kirana. Yeah,
I type on the Jamboard, is it?
sure. Can. You can type, you can take picture, you can write.
How to type?
Ken, there's a text box. Not text box. What do you call it? The post-it one. The post-it. The post-it in the menu. There's a post-it option.
Where's the menu option?
The menu is usually on the left, if you can find it.
Oh, is it sticky note?
I'm sorry. You're saying?
Is it sticky note?
Yes. Okay, that's a normal electricity. Good. That's normal electricity. So that's after static electricity. You're going a bit too far, but you don't have to delete, right? You don't have to lah. Don't have to. But I want you to focus on the lenses refraction thingy if that is what you want, right?
Okay, I can
That's
get
what you want.
lenses stuff.
Right? Yeah, lenses stuff. Refraction, I don't know, cable up, fiber optics, prisms, those kind of stuff.
Okay.
That is cool. I understand. And it's open book. Kirana, your first time doing open book, is it?
Yeah, so you can have a cheat sheet, but there's only one page.
One page of A4, you mean?
Yeah, so it's not double-sided, it's only one page.
One side. Right. So would you feel better if I advise you the things you need to have, and it's not gonna fill the whole page? You can fill the whole page with whatever other things that you feel you need, you understand?
Yeah.
Okay, so I will advise them so that you can make it now. I'll set your expectation first, Kirana. Your first draft will probably not be, you're not going to be happy about it, but your first draft will make your second one much better. At least have one first draft and then one final one. You don't just go final directly one. That's not how people understand things. Make sense?
Yeah.
Okay, so if that's how we prepare for camp and it's open book, you may find it better if we prepare from right now. And then you can use that paper immediately while doing stuff and you can prove it immediately. Again, first draft and then final draft. Okay.
Mm.
All right. Interesting. Open book. Your teacher quite progressive lah, I would say lah, progressive that way. Okay. In university, whatever course you take, likely 25% of the tests will be open book. Okay, maybe more. Who knows? Okay.
Mm.
Okay. Any other updates?
No, I don't think so.
Okay, then tell me about Cam. Just curious a little bit. Which topic you are currently, not very certain, a bit confusing. Mm. They are not
Maybe
difficult.
wait. I flipping my textbook now.
Hmm? Hmm. Questions, Aiden. I'm just curious whether there is one regarding the longitudinal wave. If there's a longitudinal wave question, that would be great. That is usually what we are confused about. If there isn't, then too bad. We'll just have to look at it in another paper.
Okay, I can try to find
If you don't
something.
find longitudinal question to be difficult, then no need. But it's just that usually people find them confusing, right? Usually.
Okay.
I
That's
don't
another study.
understand
Kirana.
how are gases collected, like the collection method.
Okay. Can we talk about it a little bit? So at least I know your chemistry is okay or not. Does that be okay? Okay. Okay. So first, they might not tell you that the gas is lighter or heavier than air. That's the most important thing. They might not tell you which one. You understand me so far?
Yeah.
Okay. So guys, I'm gonna share my screen and you gotta just ignore my screen as per usual. That's not okay. Aiden, I'm quite happy with the questions. If you want to start doing them, I'm okay. I will follow. Right? Okay. It's just that no longitudinal. Yeah, we'll find that later lah.
And the problem
Okay.
is
So Kirana, yes, Aiden.
I'm not that good at like the physics questions. I know how to identify them, but I'm not that good at doing them.
Which is great, but Aiden, I see that the wave questions are not very difficult lah. I would actually expect you to be able to do the lens one and the light one. At least do something. At least, yeah. Would that be okay?
Yeah.
Okay. Okay, so do something. Of course, you ignore the static electricity first lah. I have to explain to you, ma. Right. So now, the density is what you want to worry about, right? The density of the gas that you're collecting, and they don't tell you, Kirana. So I'm gonna tell you how to find the density of those gas. Okay, you don't find the density of those gases. Instead, you approximate using MR. You're gonna do approximation, and this happens every time. So one more time, Kirana, you are approximating the density from MR. So far, am I confusing you?
What's MR?
All right, then MR, you don't know what's MR. Okay, that's scary. I don't think it's your, you know the periodic table, right? Open your periodic table right now. If you have, do you have one printed one? That's better, right? That's better. If not, then you tell me lah.
I don't have.
You don't have a printed one. Seriously, in your notes and everything, there isn't.
I have
Really,
the online one.
Oh,
No,
this is
my notes
scary.
are all in school, like, cause teacher collect.
Yeah, I'm gonna skip MR and density for now. Okay, this worries me a little bit. Now, Aiden, I need to see your video though, unless you want to do on Jamboard.
Yeah, I'm doing on Jamboard.
Right. You're at page 3. Okay, so Kirana, wait, yeah. Okay, Kirana. So okay. So then I'll summarize without the density or the MR first. So if the gas I'm collecting is lighter than the air surrounding me, the air surrounding me, the air surrounding. I'll give you an example. A hydrogen gas is lighter than air. Then, does it make sense for you? Hydrogen gas will go up naturally. If you don't understand, tell me.
Yeah.
Now, if it goes up and therefore it doesn't go down, then to collect a gas, you usually have a tube, and the tube is somehow limit. I'm sorry, you're saying?
Are you writing something?
I am writing something. I am
Because
in
my
page.
Oh, my screen is like
Yeah,
like
at page 9. Yeah, at page 9. And this happens because iPad, so you gotta activate or go in, go out, something like that.
okay.
Let's seeing it, page 9.
Mm-hmm.
Okay. Aiden, you're stuck, is it, Aiden?
Not stuck.
Oh no, you got something. You got something. Good. Okay, Kirana. So H2 will go up, right? H2 will go up. That's what we understand if H2 is lighter than air. So
Yeah.
I have a tube like that, and the water is a bit up here. That's water. That's just normal water. And then your H2 will be there. You are collecting the H2 on top, right? On top.
Yeah.
Now, what happens if there is a CO2? So now CO2 is heavier than air. I'll just tell you first lah. Then you don't collect like that because the CO2 will not go up. The CO2 will
You should do the
sink.
downward
It's very weird.
downward.
I'm sorry, you have to do a downward delivery lah. Because why? Because the CO2 will go down. It's not that you forcing him to go down. Don't misunderstand that way. He wants to go down. So you just collect them naturally in a way that allows them to go down. Go down simply means go below air, right? Then again, H2 is naturally have to go up. So you got to catch them up there. You cannot catch them any other way, so to speak. Now, is that what you're confused or is it something else?
No, cause right, they in my textbook they did a table and one of the columns was solubility of gas in water. So like how do I know if the gas is like soluble?
Now, in that case, if you want to talk about table, which I totally agree, you gotta take a picture of the table and put it in your Jamboard. Okay, I'll explain. Right?
Next page.
Sure, if you want to.
I think I forgot about this thing. Is when the wave is moving up and down, is it like how much is 1 second? Or like how much distance does the point on a wave move in 1 second?
Sorry, are you talking about question 22?
Yeah.
Before I answer that question, just a minute. Now, Kirana, anything else you want to ask, you put in first, because you're waiting, right? Anything else you want to ask, you put in, right?
Okay.
Okay. Put it in, put it in, put it in. Then you can start to put in your paper, right? Which is a nice thing. Which is a nice thing. I want to see. Okay, this is wait. I want to see the axis again. This is the point position. Oh, so this is in meter lah. Wait. No. Yeah, this is in meter. This is gonna be weird. Yeah. Okay. So they tell you the direction of propagation, right? So, I'm trying to answer your question indirectly. Okay, indirectly. Now, this is t equals to 0, right? T equals to 0. And then the first thing I look for in this situation, he wants t equals to 0, and he gives you t equals to 0, and he wants t equals to 1. I immediately think I have to find the period, which is something very easy to do. In fact, I already have it in my mind. Now, if you don't have the period, then that's one of the improvement I will suggest lah. Because they're concerned with time, we better have the period. Period is very important. Please find the period first.
What's the formula to find period? Is it just
Uh-oh, I
T
teach you
equal
last
to
time. If you have frequency, you have period. Why?
1 over T?
Yeah, not 1 over, yeah, something like that. Something. Right, so give me the period so that I know you're correct. Kirana, there's nothing else that you're concerned regarding this, right?
Yeah, I don't have.
Okay, right, okay. So it goes like this, right? So now what he's saying is that this is simple, right? This is simple. This is also simple, correct or not? Now this is slightly more complicated. If you have to do this in lab, you'll feel the difference one. The first one is just more complicated. Why don't we just stick to the simple one? You understand? Why not? Correct or not? You understand what I'm saying? Kirana, if you don't understand, help.
Yeah, I understand.
Okay, so then let me understand the question. Let me ask the question one more time. This is more complicated. This is simple. Of course, in practice, we prefer simple stuff, but if we have to do the more complicated one, there better be an advantage. There better be. So you figure out, because the answer is in front of you. You figure out what is the advantage of the first one. If you do not know, I will brief you, right? Figure it out.
Is it like more gas will be collected for the complicated one?
Doesn't seem so. I'm just referring totally on the table. So look at the possible benefits from the table. I think the table does tell you lah. Okay. Oh, there's also the strange one, right? So your book is actually quite complete. There you go. There's the strange one, right? This is already good for your paper. Now, Aiden, half period is what I understand now. This is very important for me. Okay, let me put it another way. Let me put it that way. The period is 2 seconds. If he asks me for 2 seconds, the picture is exactly the same. Correct or not?
1 second is here.
Okay, you tell me where. Who is that? I'm sorry. Who is that? And who is that you're marking right? Oh. Okay, I'm gonna correct you, Aiden. Now, X do not move left and right. The wave moves left and right.
Yeah,
This is the rope, the medium. The medium only moves up and down.
Yeah.
The wave does travel left and right. I totally agree. So in this case, to the right only, in the right. Okay, to the right only. Okay, so the X do not move because we are describing the medium, not the wave. Obviously, the wave will move. We are not describing the wave. We are describing the medium. Am I confusing right now?
No, I understand that part.
Right. So now, so you don't say the X is moving to the right. That's the wave. Okay. You are going to think about where is X? Well, Where is x? Up and down, up and down. Where is it, right? Where is it?
Yeah, I'm just asking like how long is one period? Is this one period?
You are again very confused. Because back then I teach you period and wavelength. Wavelength is meter, period is second. This x, I just help you first. This x is a meter. It's not second. What you showed just now is one wavelength. If you feel that your teacher is not explaining this enough, well, I'm not surprised. That's why I keep explaining this from the start, right? That's why we are on the right thing here, right? We're on the right things here. This is what confuses people in exam. Kirana, look at this. Now you tell me, this is an advantage or a disadvantage?
Advantage.
Right, and disadvantage doesn't exist in other things, I suppose. Correct, yeah? So if this advantage, I agree with you, then in your paper, you better, in a sense, copy this table in a much smaller size, right? Smaller size, and you better clarify that certain things are advantages. If you don't understand the advantages, then you don't understand which method to use. Now, I'm telling you, more complicated is disadvantage, but the advantage is that you don't have to worry about density, which is nice, I guess. Okay. This is advantage or disadvantage? And Aiden, at this point, I would say that you're definitely correct. Now you go and check those two answers first, right? And let's clarify whatever doubts you have. What do you think?
I put B. I'm not really
Yes.
sure why I put B, but I just had a feeling it's B.
Now, half a period, right? Half a period. If you imagine this way, half a period means I am half through. I'm half through whatever I'm supposed to do, right? So what am I supposed to do? I'm supposed to go up and down. What? It's very simple, right? I am supposed to go up and down. Correct? And if I go up and down, because it's the peak, so I go down and then I go up first, right? I go down and then go up. Obviously, after I go down and go up, that's called one period.
Also,
I have to finish my repetition in a period, if that makes sense.
So it takes 2 seconds for this guy to go down and back up.
And up. And since we're specifying half a period, that means your B is correct lah, because your A is only quarter period. Your A is quarter period, if that makes some sense.
Yeah, now it makes sense now that I can visualize it.
Good. This looks simple. This is not simple at all. This question is not simple. It requires all your understanding. So clarify also 21. Okay. Now, Kirana, to clarify to you, this is actually an advantage, I believe, not a disadvantage.
Oh, but it's soluble. So like, what if like the gas like how to
Say your
say?
thoughts.
If for downward delivery and upward delivery, there's no water, like no water.
It can be soluble or insoluble, right? Okay, it can be soluble or insoluble. Now, think about it for a while. Oh, it doesn't matter to me, downward delivery, upward delivery. Yeah? It doesn't matter to me whether your gas is soluble or insoluble. Is that like, that sounds like, you're being flexible, right? Something like that. I'm not saying that you gotta be soluble, okay, or you gotta be insoluble. That's not what I'm saying. What? Correct? Isn't that flexibility, a benefit or an advantage?
Advantage.
Are you sure? I'm not trying to convince you in anything. I'm trying to make you think. I'm not asking you to memorize also. It's not one time. Are you sure about this?
Yeah.
All right. So there are two advantages, no? Simple and soluble, insoluble, no problem. Which means denser than air, I would say this is a limitation, no? You can call it a disadvantage. I'll just call it a limitation. You have to worry about that, correct? Does that make sense? There's a limitation. Limitation. which frankly speaking can be easily solved lah. You just flip ma. You just flip ma. In practice, you will just flip the tube ma. Is that easy one? Right? Is that easy? Right? Okay. So something like that. So you know the advantage of certain things here, and the gas range also has an advantage. With that, you have all the collection method already. Please confirm what is the advantage of the gas range. Okay. Aiden, have you checked the answer key for 21 and 22?
There's no answer key.
There's no answer key. All right, okay. I'll check for you. Yeah, don't choose a paper with the answer key, right? So do something else. Are you at page 4? Are you doing page 4 right now?
Yeah, I'm page 4.
Okay, sure. I'll just check for you.
Gas range collects small and accurate volumes of gas.
The small one, not sure whether it's advantage or disadvantage. That means he cannot collect big one, right? So not sure whether it's good or not good, but at least it's accurate. It's nice, right? It's nice. Okay. And then he said the method listed in 1.4 can be used to collect greater volume. That already makes a lot of sense already. Okay, so I need gas range for certain purposes. I need these things for certain purposes. Okay. Okay. Now please do your practice 1.2 and these two, and then why don't we start making our paper? And then we can end chemistry if you want.
Also, the practice 1.2 at the bottom.
Yes. Because that's what you're going to do in lab. I suppose you have to decide something like that. Okay, you have to decide accordingly. Then you better know, right? Okay, I'm gonna stop you here, yeah, Aiden, and I want you to think, okay? I want you to think, okay? Using 1.6 is important, and using this is important. You're using all the right things, okay? But use your logic for a while. You're saying that the light is traveling faster than 310 to the power of 8. You're saying that this is faster. Now use your physics knowledge for a while. Is that possible or not?
Yeah, it's not possible.
Because for some strange reason, they tell you that 3.0 is the fastest speed ever possible in this universe. Until this point, scientists still finds it that way. So that is still unbroken. That knowledge is still unbroken. So you're right to use 1.6, but you better use it properly. Okay, and in the sense that you are expecting a slower speed, right? So I'm not going to tell you the formula, but 1.6 divided by that is certainly not going to work very well also. Certainly lah.
Oh, it's not division.
No, it is division, but 1.6 divided by that doesn't sound like a very good idea, particularly because the unit will get messed up lah.
Oh, okay, I think I kind of.
Okay, I'm trying to use your logic here. I'm really trying to aim your logic because your logic is strong, see? So you better use it.
Is
I'm just
3.0
checking,
times
Kirana.
is 3.0 times 10 to the power of 8 light in vacuum or in air?
Vacuum. Air also the same because the difference is minimal. So you can consider them to be the same. That's okay. That's
So
going to be okay.
Vacuum and air are same thing. Okay.
Yeah, just consider it that way. You're not going to be penalized for that one. Again, figure out part 1. So Kirana, just to check, these practices got answer key 1 or not?
No.
Okay, good. No. Okay, then I have to check, right? So Aiden, if you do it that way, at least the unit don't get messed up, and then you get a slower speed, which kind of like at least logic works lah, right? You know? Okay. And that you will be correct lah, right? You'll be correct. Okay. So Kirana less than 6 blah, blah, blah. Okay. So you choose water displacement because why, Kirana? Seems okay, yeah. Seems okay, but why?
Because I mean, it's like number one is you can just choose water displacement or upward delivery. Like either one is okay.
Correct. Yeah, correct. So why do you choose the more complicated one? You get what I mean? If this is a lab, right? I know insoluble means that you can use water displacement, which is good, but it's more complicated to set up. Why? You know what I'm saying? You know what I'm saying?
Yeah.
Why don't you use the simple one, upward delivery? In that sense. Okay, makes sense. You don't have to deal with the water. By the way, the water displacement technique, after you collect, you still have to flip all the water and everything. It's very messy one. No? I'm guessing that you have never done it. Have you done it before?
No.
The water displacement. Then once you do, you will know that it is more complicated upward. It's not just the picture, really. Upward delivery, just pipe and thing, that's it. You know, you get what I mean? It's just like that, you know, and you got the gas, and that's great. Okay. So I'm not saying that you're wrong. You must be correct. Water displacement can, but you know, practicality also matters. Something like that. Okay, right. You get what I mean? Again, I'm not saying that you're wrong. Even if you're not convinced at me, at least understand that you can use both water displacement and upward delivery. At least understand. Okay. Okay, the rest is fine. Now, downward delivery definitely. Yeah, water displacement can. Okay, good. Now, I want you to take your paper and start, you know, I want you to have this understanding, because you need to fit everything in one paper, but you cannot do that in one go. You can only try to make things smaller. So in your first draft, you may have 3 papers, if that makes sense. Maybe that's what you end up with, 3 papers. Then in your final draft, you start to put it into one. You start to condense them. You understand what I'm saying?
Right? But we haven't covered like the other topics.
You are going to start now, not later. Follow me. You're going to start by putting this into your paper. Okay. And this is your first time practicing how to summarize, if you want to summarize. I'm not asking you to copy this. I'm asking you to improve it and summarize it. If possible, make it smaller. Okay? Okay. Okay, do it now, and I want to see some results. Okay. Now, why are you stuck, Aiden? The critical angle, I expect that you can calculate it. This is a bit surprising to me.
Yeah, I cannot calculate critical angle.
Oh, this is very surprising.
Is the light going? I don't know where the root comes from for critical angle.
This is very surprising. Okay, right. Okay, so critical angle basically means something like this, right? And I'm gonna erase this after I explain it. I'm not gonna wait for you. Oh. Less dense. Now, critical angle can only happen in one direction. Which one?
Less dense.
If you do not, and you are wrong. This worries me a lot.
But like here is less dense than here is dense.
Yeah, and this is dense to less dense. This is dense to less dense. And you're worried about the wrong thing. He never cared about the picture anyway. I think he cared about the picture maybe in part 3 or something. Maybe I don't know. Calculate the critical angle of the glass prism. And you are wrong if you have to rely on this picture. So that's also wrong. This worried me a lot. Already. But that's why you asked for this, right? Now, you listen to me. You listen to me. You're going to draw 2 things. You're going to draw one direction and the other direction, and you're going to draw for me the refraction. That means the bending of the light. Draw, please. No need to be accurate, but I need to see the proper bending. Okay. And your bending is correct. Okay. No need to erase. Yep. Kirana, just to confirm that you are doing on paper because I don't see any video.
Yeah.
Okay. I guess I would prefer if you have a video, yeah. Right. Okay. So the bending is all correct. This is nice. Now I will just say first, this is, in this case, in this scenario, dense going to less dense. In this scenario, you're going to draw the scenario of critical angle. If you cannot, tell me right now.
I think I know what you mean.
Okay, then draw the scenario of critical angle in dense to less dense. In another color, I guess, maybe. Nice. Nice, very good. And that is definitely a very nice critical angle. I know you know this, okay? You're Aiden, you know this. Now, I challenge you to draw this in the other guy, the less dense to dense.
It's going to be impossible.
And how do you know? I mean, if you know, you know lah. It's just that you suggested less dense to dense just now. It's just that, you know. You
Yeah.
are right, it is impossible. But do you want to try just to remember, just to make sure you remember until, you know, O-level? You want to try?
Okay.
Okay. Just to make sure you got everything, right? Then you won't make that mistake again. Yeah, that, no, yeah, no. So no, that's not how things bend, right? In less dense to dense, right? How things bend in less dense to dense is, for whatever reason, he bends closer to the normal, right? Bends closer to the normal. So if you do the second one, please notice that this is the supposed ray, and then you'll of course bend like this lah. But what you're doing totally does not make sense.
Yeah.
Do you understand why? If you don't understand, I'll explain.
You mean this, my way doesn't make sense?
Yeah, this thing doesn't make sense. Why? Because look at the black one. The black one is supposed to go straight and then it bends lah, correct? Bends toward the normal. Your blue one, yeah, supposed to go straight. It also bends toward normal. So far, so good, until you realize that the blue one is further than the black one, further away from the normal than the black one. So it will bend, yes, but it will bend here, lo. How can the blue one bend more than the black one, if that makes sense?
Yeah, that's why it's supposed to be impossible.
Good. And you understand that it is impossible. This is the reason why, no matter what you do, you will not get it 90 degree. And by the way, the 90 degree is here anyway. It's here, right? It's there. Okay. The critical is when you no longer exit is what I'm trying to say. Okay, when you no longer exit. So your critical angle drawing is great. This is great, and this is impossible. Now, from dense to less dense. Now I tell you that the drawing doesn't matter at all. Okay, I'm telling you that, and I'm trying to prove to you why. Now, please draw the entrance and exit angle here, please. The exit and entrance angle, right? Just draw for me. They kind of define the angle in a very specific way. They kind of do that.
Entrance.
Kirana, are you okay so far with the paper?
Almost done.
All right, okay. Then you show me something and then we'll try to improve it together and then you have something already.
Mm.
Okay, the way you draw Aiden is great. You're following their definition. You have to angle it towards the normal. So this is the entrance angle, lah, so to speak, right?
But there's no exit
Now, what's the exit
angle.
angle?
There's not. There's
There is,
nothing.
there is. Again, the
Zero.
exit angle is the ray to the normal. There is. Come on. You're misunderstanding something here.
Oh, this one.
The ray to the normal, right? Show it to me. Yeah, very good. Which is 90 degree, lah. Correct? You are absolutely correct. Okay. So the exit angle of critical angle is always 90, which is something that you might have forgotten. And I'm trying to remind you that picture-wise, it should have been obvious, and that's why we draw pictures and everything. Okay? Right, yeah? Now, watch me, yeah? Watch me. The N1 is the end of air. There's the end of prism, right? End of prism. Just to tell you, the end of air is 1 and the end of prism is currently 1.6. You're supposed to know this. You're supposed to know this. Okay? So far, so good? Okay. And then there'll also be the sign of the angle in the prism. The air. And the sign of the angle in the prism. The formula only consists of n, and sign of the angle. And the sign of prism is currently, the sign of the prism is currently what you are finding. This is your critical angle. The sign, the angle in the prism is what you want to find, okay? And the sign of the angle in the air is simply 1 because this is 90 degrees.
I'm done already.
Okay, take a picture or something, show it to me. Let's improve it and then let's.
I put on Jamboard.
Yes, please. Okay, let's say you know that formula and let's say you do it correctly. Let's see whether you can find the critical angle or not lah. Let's see lah. Okay, let me see. I'm gonna make it bigger, Kirana, yeah? Okay, let's not fight. Okay. Okay, right. So now, this is the first time I realized something, Kirana. I realized that you don't draw diagram. You prefer to write in English. This is the first time I realized that. Am I correct or not?
Usually I always memorize, remember the diagram.
Now, in the case of, this is not something you want to memorize, right? You understand? We are not collecting things you want to memorize. We're collecting things for you to bring inside the exam. If that makes sense.
Yeah.
Which is slightly different from collecting things you want to memorize. Okay, a bit different. You want the thing that you bring in to help you very clearly and hopefully fast in exam, right? Now, I'm seeing a preference of sentences here. Is this what you prefer to bring into exam?
Yeah.
Without the diagram, let me confirm that. Without the diagram,
Yeah.
This is totally enough for you. Really, yeah? Really. Oh, this is surprising. Oh, this is very surprising to me. I wouldn't have guessed that. Oh, I wouldn't have guessed that. Okay, let's say you're correct, Eden. I'm gonna check later, right? As you can see, the page is very crowded already, and this is why you put one page, one question. Go and move the question to the next one. I'm gonna check you do something else first. I'm very surprised. Very surprised. And you still miss the strange one. Oh, that is not good. Come on. You missed the strange one. Okay. If you're supposed to bring something to exam, better make it as complete as possible. Where's the strange? Aiden, do you have trouble moving things to the next page?
Yeah, my mouse doesn't show like a copy button. It shows duplicate.
Okay. Don't use copy button. Don't use copy. No. Don't use copy button. Okay, I tell you, because you're moving it, you're creating space here and creating spells as well. So you Control X, you cut. You don't copy, you cut, go and cut. Click the picture, cut. Then you created space here, and then you move and create another page, create another page, and then you just paste there. Control V, the fastest. Understand?
Yeah.
I will check your working because it's a bit messy. Why is it messy? You are not a messy person. It's because of the lack of space. Now, you don't disadvantage yourself like that next time, okay? Just easier to make things with a lot of space. I'll check. You do some other things. You say that you're OCD, so you shouldn't feel comfortable if you are lacking space. Correct or not? You shouldn't feel comfortable at all. Wait, am I correct or not? Am I correct? Am I correct?
I'm OCD sometimes.
And lack of space doesn't bother you, really?
It bothers me when it's like on a physical piece of paper, but if it's online, it doesn't really bother me.
That's strangely annoying to me. Okay, consider this a piece of paper, okay? So that you will not do that to
Do I
yourself, okay?
retake again?
Sure thing. Yeah, I just want to know what you write. Okay, I'm just curious how you do things here. Right?
So do I delete the other picture?
Can if you want to. Yeah, can. Yeah, that looks fine, Aiden. Okay, all right. The way you write it does feel more complete, though. It does feel complete. Okay, so I'm not saying that I agree with how you write, but you seem to be happy. That part is also important. Am I correct? If you bring this in exam, you will feel quite happy and confident. Then that itself is already a very important point. Okay. Currently, I have no comments that is incomplete. It feels complete. It feels that you can use it. It feels to me. Okay. Now this is part of your draft law. And then when you want to put in other information, you put it on this paper also, yada yada. Because you have to start to arrange stuff. Now, this is also where I say your first draft will not be one paper one. Your first draft will be more than one paper. Do you now see why?
Yeah.
Right? You see why, right? Because you're still figuring things on out. You must not force yourself to put it on one paper. That does not work. You put everything first, maybe 3 paper, 4 paper, then we start to kind of try to condense it later when it's complete. Make sense?
Yeah.
Okay, good. So now anything else in chemistry? Because if not, let's go to math or whatever you.
What's the difference between sieving and filtration?
Sieving and filtration. Okay, filtration. Have you held a filtration paper before?
Yeah.
Then do you see any holes in filtration paper?
Like filtration is like only one hole, then sieving like got like tiny hole. Like many tiny.
No. Filtration paper not supposed to have hole. Not supposed to have hole. Come on. Wait, what do you mean by filtration paper have hole?
No, because like when you make the cone, right, then it got like a hole at the bottom.
Which is unintentional and not supposed to happen. You're supposed to not have that hole. Correct or not? Wait, correct or not? If you have too big of a hole, for example, if you have too big of a hole, then things will pass through, which is not exactly what you want from a filtration paper. Correct or not? Okay. Make sense?
Yeah.
Okay, did your teacher say that you want the hole or you shouldn't make a
there's naturally like a tiny hole already at the bottom.
Tiny hole, tiny hole. So we don't want a big hole, right? We don't want big. Now the difference between a sieve is that a sieve have many tiny, right? Correct? Correct or not? Correct or not?
Yeah.
So a sieve cannot do what a filter paper do. A filter paper also cannot do what a sieve do. So a sieve enables you to separate small solid from bigger solid, if that makes sense.
Yeah.
Because of the small holes let small solids through. Now, whereas filter paper separates solid from liquid, if that makes any sense.
Mm.
And that is also something you want to put on your paper. That should be simple enough, makes it complete. Okay, do that. Ask more questions. So Aiden, your critical angle question, yeah, it's correct. Yeah, the answer is correct, and you did use the right formula, which does makes me happy. Okay. Now, are you sure you don't want to ask anything else
I probably
from
won't
that
know.
question?
From the question, I don't think I have anything
You're okay.
else.
Good. Now, remember one thing though. Remember one thing. As I promised you, yeah, very surprisingly, you don't use the picture at all. At all. Very surprisingly, right?
Yeah.
If that bothers you, you should ask. If not, then that's okay. Okay.
That
Now,
means
one
that
thing about
means-
critical angle, you're saying?
does that mean that I have to go and draw that diagram on my own, like the less dense and dense one?
Well, it depends on you, brother. Because I find that when you draw, you start to think properly. When you try to think in your mind, it almost never works one. Cannot blame it, you're not getting enough physics knowledge to do that. But drawing means it helps you, and drawing takes very little time. It's what I feel how you do things. That's why I force you to draw. Nobody else is forcing you to draw. Nobody else.
Yeah.
I force you to draw. I don't draw for you. In short, I don't draw for you. When I force you to draw, you draw correctly. Then I force you to think using the drawing. You start to think correctly. You notice that?
But like if it's supposed to be drawn on the actual diagram, how is it like?
You're bothered about the actual diagram right now. It's what you're saying, right? You're bothered by it, right? Okay,
Yeah.
I'll tell you something about the diagram. The diagram is total internal reflection. It's not critical angle. Am I correct?
I don't know
If
what
you
is
don't understand this, you're gonna tell me right now. You're gonna tell me right now.
I heard about total internal reflection, but I don't know what exactly.
Oh, it's a very simple thing. No, I guarantee it's very simple, right? Okay, again. Now I am redrawing. Kirana just checking your opinion.
I no more question already.
All right, very good. Once you put it on paper, then you can, if you're ready, then you can shift to other topic, right? Okay, less than, right? So your first arrow was not critical angle. It was a normal pass lah. That's a normal pass. Then your second drawing is the critical angle one, which looks like this, right? Now, you're gonna tell me what happened if I make the angle even bigger, right? Adel? That's even bigger, right?
Gonna go the other way. Like it's gonna.
You're gonna draw something for me, and let's see whether you're correct or not. Now, this angle, you're gonna be very precise with me. What is the angle involved here for the yellow and the green one?
What is the what?
The angle, please. Like critical angle involves 90 degree, right? Okay, something like that. Then, this yellow green guy.
Angle of reflection.
Yeah, what's the angle involved here? The angle of what, sorry?
Reflection.
Reflect, right? You're saying reflect, not refract, correct?
Yeah, the one with
Reflect.
the L inside. Reflect.
Yeah, so you are correct. See, your physics is fine. And this is TIR, no? Total internal reflection, no? Fancy word for I no longer refract, I reflect. Fancy words lah.
Oh,
But you know that already. You
Wait.
know that already. You can understand, you know that already. Okay?
yeah.
So now look at the diagram. Look at the diagram. The diagram is 45 here. It means it's 45 here and 45 here. Why do I bother? Because I'm trying to figure out the angle. I'm trying to figure out the angle of, I'm sorry, I'm drawing the wrong thing. Oh, no, I'm sorry, I'm drawing the correct thing. So the angle here is 45, 45, see? 45, 45, which obviously that's total internal reflection. It's obvious that we are not doing a refraction here. We're doing reflect, obviously, right? Correct, right? No surprises here. Okay? This is obvious, yeah? Correct, yeah?
Yeah.
And this is not a mirror. We're doing reflection not on a mirror. If this surprises you, you gotta tell me immediately lah.
I can kind of understand that.
Right? Now, if this is all true, then I'll just say that 45 degree is bigger than 38.7 degree, and all this makes sense. I'm not saying that the diagram is useful. I'm just saying that it makes sense. Your answer 38.7 has some sense, therefore. It's correct anyway, I checked already.
Can we discuss email?
Yes, Kirana, I'm waiting for your question. You don't have to ask. You don't have to ask. I'm waiting for the question. Right? Where is it? Right? Where is it? I'm always looking at your Jamboard and waiting for the question. Right? You don't have to ask for permission. Aiden, I take it you're trying to understand something. Is it correct?
Yeah, so if this is 38.7 degrees,
It will be critical angle 90 degree instead.
then the normal is here, then the 90 degree will just be like that.
Your 90, come on. Yeah, correct. That's the exit. Yeah, that's the exit rate, which is still critical angle, which is still.
But then
Still.
this
And
is
if you go
less
lower than 38, yeah, go from the dense to less dense one lah. Oh, you are.
less
Go
than
from the dense to less
oh,
dense.
inside here to
There's
outside
a,
here.
yeah, from inside to outside. Yes. Don't do the less dense to dense one. Don't. I understand what you're saying. I understand. Actually, I made a mistake. Okay, this is my fault. My fault is I focused on the dense lesson. I should have focused on this part. That was my fault. I apologize. I should have talked about it here. That's my fault. My fault entirely. Okay. But you're right lah. In essence lah. In essence, you will have that lah. I'm sorry. See, I put the wrong point again. Actually, I analyzed the correct thing. What am I talking about? Okay, I'm sorry. I'm analyzing the correct thing. I'm analyzing the supposed dense to less dense. I am correct.
Yeah.
You're thinking about the wrong point. This is the wrong point. This is the correct point. Okay. Okay. I'm still talking about the right point. Okay. So I'm going to go to Kirana for a second. Now, those are good questions. Okay. That kind of covers all the exams you need to know. From now on, the question will appear to be quite similar. So now, Kirana, tell me what's your question here?
I'm not really sure like how to work it out.
Okay. Okay. Then how to start, right? Basically, correct. How to start.
Like I know how to start, but then like for the 4 over 2x minus 1 minus 8 over 2x
I know. Okay. Then,
plus 1, like you just cross, right? Like cross.
And dear, okay, crossing.
Like four.
Kirana, I need you to abandon. No, I'm ready. I'm worried here. I'm worried. Okay, right. You tell me what you're gonna do in primary school, right? Minus. Let's say this is the case. Now, what are you going to do here? Tell me. This one you certainly know what to do.
You times 7.
Go. Write down. Don't say. Kirana, don't say stuff. Good. This is math. Aiden, you're already at that question, right?
I don't know what I'm doing.
Okay. Kirana, what you're doing is correct. You can stop now. Now, do you call this cross, Kirana? Is this what crossing is to you?
No.
Okay. Now, I will clarify what is cross. And you are right. This is not called cross. It's not called cross. This is simply called equating denominator, ED for short. This is not crossing at all. Okay. Just to be clear, a cross multiplication, you might want to, maybe that's what you means something like that. then you kind of do that across, correct? Across M, right? And then you have x equals 1 times x equals 2 times 3. Now you memorize things, even though you understand very well that this is correct and this is not a cross. You look at this, you look at two fractions and you want to cross them immediately. That is bad thinking, Kirana. That's not thinking at all. Because you know what is correct. This is what you're supposed to do. ED, not cross. Am I making any sense? If you're just looking for a step to do, you will fall into this mistake from time to time. But if you understand that you know what to do, you will do the correct thing. ED. Show me your ED, please. Now, Aiden, you say that you don't know what you're doing, but it's probably not bad. The two rays that you're drawing is probably good.
The first one I know, but it's the second question, the II.
Now, let's get it clear first and second here. So I'll call this the first one. Call this the first one, and then call that the second one. Okay. That's very confusing. The first one must be correct. I mean, what can I say? First one is the easiest one. First one, right?
Yeah.
And so by using the first one, you have located the image. That's the most important thing. The second line you draw by tracing back low, this must be parallel, and this therefore must pass through the focus. You're working backwards for the second line. If that is what you did, you are absolutely right, and I have no doubts regarding your lens. You understand what lens means, really. To me, you're fine. Okay, so that's one, and the other one, totally fine with that. You seem to know what you're doing. Okay. Okay, now let's see whether you can do 3 and 4. I did try to teach you 4, but let's see. Okay, so far so good, Kirana. You gotta simplify everything, yeah? Gotta simplify everything. Are you going to do here? This is gonna be interesting. Kirana, you're doing a cross, am I correct?
Yeah.
Now I'm testing your mental strength, okay? I'm testing your mental strength, so listen to me, Kirana. Are you sure you're correct, Kirana? Are you sure you're correct? Are you sure you can do cross M here?
Yeah.
Now you want to do cross M on the wrong situation. I have to correct you. Are you sure right now this is the right situation to do cross M?
Yeah.
Are you sure you do the cross M properly?
Yeah.
I have no further comment. I just hope that you're correct. Okay, you will find out later when you check the answer key. Okay. Now, Aiden, are you stuck?
I don't know what they mean by the thing is broken.
This is a very standard how to say, standard way. They only mean something like this. Okay, they usually say something clearer than this. They say that maybe the top of the lens is missing. Maybe that's how they say. Please God. Okay. So like for some reason, the lens is cut off. This one, he say part of the lens is broken. Okay. This is
Okay.
quite common for them to ask. So you ask me, you're gonna ask you, do you think the image will still be formed?
It will.
Okay. Then what are the changes if there is any?
There'll be lesser light rays going to the image.
Therefore,
The image is less bright.
and that would be the answer.
Oh.
That would be the answer. Hey, Kirana, you're a secondary student, yeah? Remember, yeah? If you're a secondary student, you are definitely allowed to, do the calculator, right? Just a faster way.
Can I continue on the next page?
Oh, sure thing, sure thing. Oh, sure thing. You're not wrong, Aiden. So no comments for now. You're not wrong. So far, so good, Aiden. So far, so good. At around 6 o'clock, Aiden, I have to be offline for around 4 minutes. You should be doing your questions, and then I'll be online again, and I'll check in. Would that be okay?
Yeah.
Okay. Okay, Kirana, you are presenting using the formula, which is great. Now, Kirana, tell me, are you typing the formula right now, or are you
Yeah.
using the... No, please don't type the formula. Don't forget what I teach you. Come on, Kirana. Oh, come on. I teach you never to... You got to write the formula, but you
Is it
cannot
the
type it in the calculator.
polynomial?
It's troublesome. Yes, the polynomial. It's just faster. Remember what I teach you. Typing this in the calculator in exam kind of just increases the chance of error by so high. Don't do this in exam. Don't. Yeah. So therefore, don't do this in homework. Don't. There's no need. There's no need. You're a secondary student now. Good answers, Kirana. Let's check our answer key first.
But this one no answer key. It's like some revision paper from my teacher.
Oh. I'll just check whether there's a mistake or not, but continue for the next one. Do you have a next question? We can still do maybe one or two more. Kirana, you did a double minus correctly. I spot one double minus. Excellent. Eh? I could spot. Kirana, I don't think you make any mistake lah. Hopefully, yeah. Yeah, correct. Interesting question. You tell me if you can do it. Yeah. Okay, Aiden, you're learning, right? You're learning, you're redoing that very easily already, right? Very, very easy, right? Again, Aiden, you notice that this something divided by something is not an official formula. It's not. It's not, but it will always be correct one. At least in O level, you always.
Must I leave it in standard form or like that can
The standard one will contain the index, the refractive index of the first guy. The first guy's refractive index is 1, I suppose. So you don't have to include it in. You get that. But again, I don't think they ever. Yeah, no, you'll be correct. You're always correct. And you don't have to say, you don't have to write down the formula. The formula never gives you mark 1, even in the paper 2. Formula never gives you mark. If you don't write down the formula, but you do it correctly, the examiner will also notice one. That's fine. Writing down the formula is for your benefit, not the examiner's benefit. The examiner knows what's going on. He see you immediately, he knows one. Oh, this guy is right, this guy is wrong. It's a physics teacher, huh? Okay, Kirana. So what do you think? You found interesting. You identify one error, right? Do you think there's another error? Just checking lah, because he say errors, right? Maybe there is more than one. I don't know. I agree. There's at least 2 lah. At least 2. Hey, looks like your mastery of the formula is quite good lah. You don't look confused at all to me. So Kirana, I'm not sure why you're asking me this question lah. You look great, you know. You look good.
I don't understand what the equation mean by has no real solutions. Is it the arrow?
Oh, this one. So this guy remember you're partly a math student, so the inside is negative, right? The inside of the quadratic is negative, right? Your teacher should have mentioned this. If the inside is negative, you press calculator, they give you math error, right? Now, math error is not your error. Math error simply means no answer, which is the answer lah. The answer is no answer, right? Now, if you press the polynomial, you'll find an answer with. You will find an answer. The answer has plus something something I, correct? Have you encountered that already? Now, I means imaginary. Now, you know what's imaginary? Imaginary means imaginary. Not yet? Okay, then I encourage you to use your calculator polynomial on this one, the wrong one. Try doing this and let's talk about the answer and then we can end there. Just checking, Aiden, are you stuck? You seem stuck, huh? What?
I'm kind of stuck because it's not even going in the proper way.
You're talking about the ABC one, right?
ABC, yeah.
Why are you stuck? Why are you stuck? Okay, let me check again. Yes, Kirana, sorry, you're saying?
Yeah, it's like 3/8 plus
something,
then got I.
The I means that it is not the answer. Okay, sorry. I'll say it nicely. The I is not the answer. The I indicates that this answer is imaginary. Whatever that means is not real. Okay. To you, it is the same as no answer, even though the answer seems to be giving you something that looks like answer. The I tells you that, oh, this is the no answer type. The I. You must look for the I. So consistent, right? Consistent, no? This question has no real answer. It's just that the student make an error. That's why. That's why he conclude like that.
Mm.
Your conclusion is that the answer is there one. Good question. Now, you wait until the next session. We close here first for you, Kiran. Okay.
I don't have any more questions for AMAth. I finished the whole paper already.
Good, good. Then, if possible, we talk about AMAT, right?
Okay.
Or, in fact, I want future email. I want that, right? That's what we're gonna do, right?
Mm.
Okay, I'll see you later, yeah? And now for you, Aiden.
Bye-bye.
But now, this critical angle of glass is correct. Your drawing is also correct. This is dense to less dense. And Aiden, if we just refer to the previous drawing, right? You will notice that the drawing doesn't matter in finding critical angle. I keep telling you that. This one, you seem to be complaining that the drawing doesn't help you. Well, that's what I'm telling you lah. The drawing is not needed for critical angle. You gotta get that into your mind.
Oh, then in that case,
Mhm. Now I'm gonna stop first. You're gonna continue. Yeah, I'm gonna go on offline for about 5 minutes. Okay, then.
Okay.
Okay. I'll see you later. Yeah. Now do something else. If you cannot, then do something else again. So, standard. Eden, just checking you can hear me. Yeah.
Yeah, I can hear.
I didn't see any questions so far. You seem okay. Can I clarify that?
Yeah, but I just want to verify. Does frequency change when it goes into another medium?
Okay, that is what I told you, but I didn't explain yet. Frequency never changes, not in order. Never. You produce the frequency differently using your vocal cord, but once you produce them, they don't change frequency-wise, like frequency-wise.
Also, even
They
if
don't.
even if it goes
You
into
go through whatever medium, go through this, go there. Changing frequency is very difficult, very difficult. So in O level, it doesn't happen. You only change frequency at the production. So you don't confuse that. When you're producing it, you can change it quite easily. Once produced, not gonna change.
But the
Okay.
production part
That kind of helps a lot. You're saying? Sorry, I cannot hear you.
The production part isn't tested in O levels.
No, absolutely not. It's
Lucky.
A level. Yeah, A level. Okay. So that should help you a lot in doing questions, right?
Yeah.
Good. So go ahead and continue. Looks like we're doing useful stuff here. I have another student on site today. Just to take sure. Really, A level was not I know what I know.
Let me run a bit. I think the UK is good to
Which question are you doing, Eden?
I did
Right now.
20.
Correct, 27.
Now I'm doing this 20.
Eden, you are wrong. I want you to find a mistake. I will call this a silly mistake. It's silly, yeah. I don't think it's fun. No, this is fun. I want to see the real expert. I want to see how far they if you have a question. Because if not, we can go. Maybe no harm.
I've never seen it before.
This one, if this is the case, it's not difficult. I have to explain.
Yeah, but I just don't know what p-value significance.
Let me explain. Let me conclude. Do you have a pencil?
My friend gave me his notes, sir.
Eden, you haven't found your mistake yet. You get it.
Yeah, I haven't yet.
It is a silly mistake. I believe it is a silly mistake. It's a big one. No. I'll just use this. Take a one. Population. Population is the real thing. Population, if it is normal, will always have a mean time. And then you always have the distribution. In this case, we choose the standard.
Yeah, so that's not.
Now, my challenge to you is draw. I want to see your drawing because it helps a lot. Draw and then standard deviation. How would you draw this properly? Right. Eden, do you want me to tell you your silly mistake or shall we leave it?
Yeah, what's the mistake?
Okay, it's a silly mistake. You forgot something important.
What's that?
Okay, in the second sentence,
The wave crosses a boundary PQ when it increases between crest regions from
It's 0.25 and 0.5.
three what? Tell me, Eden, three what?
I can't hear you properly.
Oh, three what? Three changes from three.
3 to 1.5.
No, you're skipping something. That's very bad. Three what?
3 cm to 1.5 cm.
Yeah,
Oh,
you
the
still don't get it, huh?
I think it's cm.
Yeah. Even when you read, you skip the CM. Did you notice that?
Yeah.
It reflects how you see the question. It really reflects. It reflects that you're not caring about the unit, and that's why I say it's a silly mistake, because you're concerned. So just to confirm with you, Mateo, how many percent is this? Do you know? Okay, then it's not that you have to remember, but it's very useful. No, it's much bigger. Like it's way bigger than. It's way bigger. Like when I say way, I mean way bigger.
25 is 2.5 signification.
Something like that. Okay, I'll make it easy for you. It's 70%, which means this is currently around 5, something like that. Exact number is around 75, okay, right? Divided by 5, so then this is 15, right? This is 15. Now, 2 deviation, okay, right? This is 35. So what is this percentage? And then finally, last one. Okay, with all this, we can start this 22. Okay, so what's the percentage? Okay, if here, or
This is about 5%.
okay, something like that. So the whole standard deviation is around 95. And 3 standard deviation is around 0.9, which is smaller than 1%. So this is almost nothing. And so you know why they use 3 standard deviation. So these numbers will be very useful. I can one more thing. This is normal y value. Okay? So sometimes you go to C.
Oh, so it's when you map it to
the first part is always it's
it's you map it, it's you standardize.
you standard, which means what is it?
Wait, this one I know already. The hard part I don't know about the A-level one.
I'm testing. I'm testing it. Because we need to talk about all this immediately. I guarantee you they use this all in hypothesis. What is the Z value of movement? If you have to think, I'm good. That's why. Yeah, very good. 1 and 1 minus 1.
Oh, yeah, one.
Then this one is 2 and minus 2. So you always map one standard deviation into 1. Okay, good. Now you understand. Now, this number you memorize, right? 70, 95. Aiden, just to check, are you stuck or not?
Yeah, it still gives me the same answer, although I change the unit.
Right. Should be number. Hopefully this is not hard for you. Yeah. So the population have mean and the population of standard deviation and then deviation. Now, with hypothesis testing, the population is supposedly changed. Supposedly. And in local A level, they never change this one. Deviation, right? Only the mean. They only talk about whether the mean change well or not, but change. Okay, so only the mean. Now, what happens when you do sampling? Now you're gonna tell me
what happens when you do sampling? What do you get out of the sample? Not the population, right?
Or
Yeah.
you get what out
Another graph.
like it has to be above that first. Then we call it a photo.
Correct. So, but what is this sample? This sample also has its own mu and also has its own standard deviation. So let me clarify first that this sample is not the population. Correct, yeah? So now this mu and this mu, you say you read the note. So what do you think is their relationship?
This is the actual unit. This is actual unit.
And this is mu of the sample, right? Mu of the sample. Now,
If the formula says like experimental results.
correct. But the experimental is not the whole population.
Yeah.
The experiment is always just a sample
Yeah,
of the
it's
population.
like it's always like
Experimental, which means, keep it simple. This mu, even though they are not the same, doesn't mean that the population mu has changed. You must understand that. But this is
like a very small sector.
correct. But if you go above 30, you can
30
do something. You can do something about it. If you're below 30, there's a further requirement before you can use it. Okay. Aiden, you look stuck.
Let me know if
Because the next 29 is going to really work, so I'm trying to remember everything.
Oh, never mind. Don't do 20. You want me to what?
When you're talking to Aiden,
Okay, I'm going to do it.
Oh.
Thank you.
okay,
For now, thanks. Okay, so you don't worry about that. Question 30, you can talk about it. Question 30 is not difficult at all. In fact, question 30 is easy. Now, Aiden, can I confirm one thing? You're happy with just talking about physics today?
Yeah.
AMAT is not worrying you that much, and chemistry is okay. Is that correct?
AMAX, I think I got good at AMAX.
Good. Good. Then, chemistry.
Chemistry is worrying a bit, but not worrying as much as physics.
Then at least we can talk about it a little bit more, okay?
And
Okay. You forget 29 and 31, doesn't matter. Yeah, just 30 is fine.
yeah.
And then maybe do one more question. Already jumping to the question, right? If the sample is 91 and the mu is 1, this does not mean that you can conclude the population has changed. Why am I saying this? Because this is frankly speaking past data.
Yeah, this is like a million lah. That's significant.
However, this million, the hypothesis, if you have to do a hypothesis, somebody is somebody is saying that the population has changed. That means the past population is no longer the new one. That's somebody saying. And so you have hypothesis testing. You have to prove it somewhere.
When it comes to that, it's a lot of the class. Also, I have the time that the thing has changed, then I'm supposed to come up. From this further exchange or not lah.
Let me prove it in the sense that with the hypothesis testing,
Then you check, see.
whatever possibility. Then that's the idea of hypothesis testing. Okay. Now,
Also, in actualism, if I do sampling, sampling is just me thinking this, but I'm going to assume this. But if I hypothesis, I'm checking the error where my sample, what my sample says about this.
to be fair, let's say you go to a company. They take samples periodically. Let's say you're producing, I don't know.
Also, you always have
Right, MacBook, you're producing Mac. So they don't test every MacBook that's facing. They just test 0.1% of MacBook. So they take sample regularly. And then if the sample seems to suggest that nothing has changed. Nothing will be done. But one day, the sample seems to suggest that something has changed. So what's the criteria? That's the hypothesis. So even though you are taking sample, not because somebody says something, every time you take a sample, you have to make a conclusion. If not, why take sample? Take sample is a very expensive one. It's a very expensive. So every time a sample happens, this happens, and then you have to decide. So now I'm going to give you the very rough logic. Look at it. If the supposed past population is kind of this wide, they're not very wide. Okay. And then you take a sample. You take a sample, and then the mean of the sample is here, slightly off. You will conclude that something changed if the sample distribution is. It looks very sharp. Wait, this is very sharp compared to this is a very good indication that something has. However, if your sample mu is one, this is 1, let's say this 1, but the sample decision looks like it. There isn't much conclusion.
Yeah.
This is less defined. The sample is less defined. So the credibility of the sample is too wide.
Wait, when I take the sample, how many of the sample are
There are 30 or more. Okay, so what's the criteria? One is not a sample. That's no longer.
That's one sample.
Yeah, which is, per sample, but that's already nonsense. Less than 30 is okay. You will see those kind of things. For example, your sample is 6. What the heck? Yeah. When you do personal experiments, it's very difficult. Like, you want to know whether your swimming time has changed. You cannot just swim 30 times. Right? Okay. So you swim 6 times. But it's okay if you assume, that's the keyword, you assume that the whole population is normal. If the population cannot assume to be normal, your sample be bigger than 30, you don't need to know what. That's the key. What do you mean? The population distribution can
a normal
distribution distribution is not always normal. The distribution can be not normal. So that's the only thing for A11 local. I assume that you will be the same place. So those are the physics. So this is the only thing you have to understand. And this has something to do with P or the Z value. This is whether the sample is sharp enough or not sharp enough. Something. Okay. Now, having said that, Eden, use or no? Then can I confirm that you don't have any questions?
For now, not yet, because I haven't faced the problem.
Okay, sorry. It's not hypothesis. You don't assume that something changes.
That's like, I don't know what it's like. They say it's in the prevalent.
Looking for that table. That's it. Then, yeah, one star. Aiden, I'll comment on question 25 and we have to end for now. Yeah. So Aiden, this is your F and this is your 2F. Last time I was showing you that 2F is where you have this and that. That is A not C.
Oh, okay.
But why is that so? It has something to do with the race and everything. But 2F is where it's constant. And only 2F has the same things. You can treat it as memorization, you can treat it as an understanding. For now, that's
Yeah.
okay. Right. As for now, you're using this one as 35, so I'm very happy. And this looks like a correct answer. So it's cool.
Mm.
I'll see you tomorrow.
All right.
Job.